We're evaluating a quotient of what appears to be a bunch of powers of 3. Indeed, 27 is 3 cubed, 81 is 3 to the 4th. Of course, you have 3 there. So normally for a problem like this to work out quote nicely, we would like this entire object to reduce down to an exponential of 3 raised to some multiple of 4. Now again, these problems are designed to work out nicely. If it didn't work out this way, you wouldn't be able to extract the 4th root. Notice that when you extract the 4th root, that's equivalent. Like if you have the 4th root of x like this, that's tantamount to saying x to the 1/4. Okay, and so laws of exponents would work out favorably in this case because this 4 right here would cancel with this 4 right here. So again, normally you got to kind of game these things. This isn't necessarily a competition problem, but they're designed to work out nicely. You anticipate a nice clean integer answer, although a priori you wouldn't necessarily know that. If it's a competition type problem, you would expect an integer answer. So let's get moving. Now I've already done most of the work right here. I just rewrote the problem down here. And again, as we stated earlier, everything is in the form 3 raised to the k, right? And so we got a common base 3 cubed for 27, like I said earlier, 3 to the 4th for 81. Okay, so you see how that works out though when you actually multiply. There's another law of exponents that says if you have a raised to the m, you're normally thinking of m as being an integer, although these rules hold for the rational numbers. But if you have a to the m raised to the n, if you think of those as just natural numbers, m and n that is, you're actually saying I have n copies of m copies, but that's m times n copies. All right, so that would be a raised to the product mn. Okay, that's kind of a ghosty looking a there, but anyway, it's well known, just a counting thing. Literally, you have m copies of a right here, and you have n copies here, so you have m times n copies of this base a. All right, and that's what we did going from this step to here. 3 times 29 is 87. 4 times 18 is 72. And 4 times 13 down here, 4 times 13 is 52. All right, so now what happens on the next line is very predictable. You factor out the greatest common factor of both the numerator and the denominator. In that case, it's one of the terms present. 3 to the 72nd is the highest power of 3 in the numerator. We factor that out. And correspondingly, 3 to the 52 is the highest power of 3. And so you see we factor those things out. And lo and behold, we have a well-disguised version of 1. 3 to the 15th plus 1, whatever it is, these two factors are going to cancel, right? Okay, they're going to cancel because that big number divided by that big number is just 1. Okay, so what we get right here is the 4th root. We get the 4th root. And again, properties of exponents. You have 72 copies here, 52 copies here. 52 of the copies down here will cancel with 52 of the copies up here, leaving 20 copies. And so you'll have 3 to the 20th. All right. And again, this can be rewritten. If you feel like using rational exponents. 3 to the 20th raised to the 1/4 power. All right. And again, we're doing a rinse and repeat here on this rule right up here. When we have something in this form, you can multiply the exponents, and that produces, let me get a little more room here. That produces 3 to the 5th is the answer. 3 raised to the 5th power. Okay, now that's not too hard to do in your head. 3 times 3 is 27, 3 times 27 is 81, and 3 times 81 is 243. All right, and so the final answer on this one is 243. Indeed, it worked out nicely, and it was homemade and was designed to work out nicely. All right, so Um, that's the solution. Good night.